So good morning students, welcome back. Today we will discuss some objective questions related to optics. So this will be the 8th lecture on NEET class and JEE. So now let's start the question of first for today. See students, I'm going to explain the language of this question. A fish looking up, okay, through the water sees the outside world contain circular horizon. If the refractive index of water is 4/3 and the fish is 30 centimeter below the surface, then calculate the radius of circle. Look students, actually we are given a fish, okay, in the water, okay, and it is 30 centimeter below. So what is the depth of that fish from the surface? That is 30 centimeter, okay, from the surface, and that fish can see the outside world in a circular horizon and its radius is r. Okay, this is air, outside world, and this is water, and having refractive index 4/3, and this fish can seize the outside world in a circular horizon, in this circular way, and we have to find its radius, and the depth of the fish is 30 centimeter. We are given four options: 50 centimeter, 34 centimeter, 100 centimeter, either 44 centimeter. So we have to find. Okay, now students, look, first of all I'm going to remove this question. You can take a screenshot, you can write this question. Calculate the radius. We have to find the radius, and we are given the four options. First of all, I want to clear you students. Look at this is 90. When angle of refraction in rare medium is 90, in that condition incident angle is said to be critical angle with respect to total internal reflection. If this is IC, critical angle, okay, if this is IC, that is also IC, because that is alternative angle. In Z shape it forms alternating angle. So this is IC, that is also IC, because these are alternative angle. And this is the radius that we have to find of a circular horizon, and depth of the fish is 30 centimeter from the surface. So now students, we know the formula: sin I upon sin R, mu2 by mu1. Okay, mu is the refractive index. We can also write as n2 by n1. Refractive index we can represent either by mu or either by n. Okay, air having refractive index 1. So sin IC and sin R. Angle of refraction we are given is 90 in rare medium. So this is 90. Mu2 is the refractive index of air, that is 1, and mu1 is the refractive index of water. Understood students? Air having refractive index mu2, that is 1, and mu1 is the refractive index of water. When refraction angle is 90, incident angle is said to be critical angle. Understood? Now students, sin 90 is 1. So we'll get the first formula: sin IC equals to 1 upon mu1. Equation number first. Understood students? Now the second thing, in this triangle POS, this is the point given name as S in triangle POS. In triangle POS, I'm multiplying sin IC. What is the formula of sin theta? Perpendicular by hypotenuse. Okay, so this is R is perpendicular, this is 90. So R is perpendicular, and opposite to 90, this side PS, this side is said to be hypotenuse. How can you find? Using Pythagoras theorem. R square plus this is height h square. So you can write root R square plus h square. Equation second. I applied sin IC in this triangle. Now compare both first and second. When left hand side equal, right hand will also equal. So you can write 1 upon mu1 equals to R root R square plus h square. Now cross multiply students. Root R square plus h square multiply with 1. So what do we get? We will get R square plus h square. And here we will get mu1 R. Okay, so now taking square both the side. Root will eliminate R square plus h square, and it become mu1 square R square. Understood? Transfer. Look at, we have to find radius. So look students, h square equals to mu1 square r square. Transfer this r square at that side, minus r square. Okay, we can take common as r square. We can write mu1 square minus 1. We have to find radius. So h square divided by the term. Okay, mu1 square minus 1. Okay, now students, when I remove square, there comes root. Okay, so look students, now put the values. H, what is the depth of the fish from the surface? That is 30 centimeter. Here we can write as 30 square. And what is mu1? Mu1 is the refractive index of water that we are given as 4 by 3. So we can write as 4 by 3 square means what? 16 by 9 minus 1. So we can write as 1. Okay. So now students, finally we can write as square root of 30. There is 30. Okay. And when we take LCM, okay, LCM is taken as, we can take root, taking the LCM as 9, 16 minus 9, so this will be what? 7 by 9, we can write 7 by 9, okay. Square root of 9 is 3 and 9 will multiply with 30, 90 by root 7. Root 7 is 2.64 and when 90 divided by root 2.64, we'll get finally as 34 centimeter. Okay, you can calculate. So which one is the correct option? Oh yes, option B is the correct. So what should be the radius of that circular horizon path? That will be of 34 centimeters. So B is the correct option. So now students, question second, another important question. Look at a rectangular glass slab ABCD. Look at ABCD. This is a rectangular glass slab that we are given of refractive index mu1 is immersed in water. Refractive index of this glass slab is mu1 and it is immersed in water in another medium that having refractive index mu2. Water of refractive index mu2 and the important condition mu2 is greater than mu1. Mu2 is greater than mu1. Okay students, he is asking a ray of light is incident at the surface AB. Okay, look at students, this is the incident light rays, okay, on the surface AB. Now, a ray of light is incident, so angle of incident we have to find. So this you have to find alpha. Look at students, this is the incident ray and this is the angle alpha that we have to find. We are given the 4 option. Alpha, what should be this alpha? Incident angle, this is normal, this is incident ray on the face AB. So alpha is taken as incident angle, okay. Sin inverse mu1 by mu2 cos sin inverse mu2 by mu1. Sin inverse mu1 cos sin inverse 1 by mu2. Option C, sin inverse mu1 by mu2. And option D, sin inverse mu2 by mu1. We define this angle alpha. So look students, one condition we are given, mu2 is greater than mu1. Okay students. So let's start the numerical. Now I'm going to remove the language of this question. We define incident angle I. Okay. So look at students. First of all, I'm going to explain the diagram. When the light ray is incident, it travel like that. This is, look at, mu2 is greater than. Outside there is a denser medium. Inside there is a rare medium because we are given mu2 is greater than mu1. So light suffers total internal reflection. This is the total internal reflection, okay, and this is the normal, this is I, this is R, angle of refraction, angle between normal and refracted ray is called angle of refraction R. This is IC. Why? Because light is suffering total internal reflection, TIR. In that condition, the incident angle is said to be critical angle. So this is IC, okay, and this will be 90. So look at students, a triangle, give the name as suppose AOB. Okay, suppose this is AOB angle. In this AOB, in triangle AOB, sum of 3 angle is 180. So I see R plus 90. IC plus R plus 90 will be 180. So what should be IC plus R? 180 minus 90, 90. we have to find suppose R, that will give the 90 minus IC, our first equation. Understood, students? Now students, look at the second thing. We know one more thing. Sine IC is mu2 by mu1. So what should be IC? Okay, that is sine inverse mu2 by mu1. So remember these two values, the value of R, 90 minus IC, and this, that we found by the condition of total internal reflection. Just we did before in the previous question. Now students, I'm going to remove this mathematical portion because you have to find further. So just remember the two values, the value of R and value of IC. Later on we'll use in this numerical. So finally I'm going to write the value of R as 90 minus IC. Okay students, we can write this. And the second thing, IC we are having as sine inverse mu2 by mu1. Okay. Now students, finally, look, I'm going to applying Snell's law for the face AB. Applying Snell's law of refraction for the face AB. For face AB, mu1 by mu2 equals to sine alpha. Look students, sine alpha by sine R. Look at students, alpha is an incident angle. Snell's law is what? Sin I upon sin R is mu1 by mu2. The ratio of sin I and sin R always remains constant. That is called refractive index. Okay, so mu1 is the refractive index of denser medium, of rare medium, and mu2 is the refractive index of denser medium. So as angle of incident we are having alpha, and as the angle of refraction we are having R. Now students, just we'll solve this mu1 by mu2 as it is. What can we write as R? Look at students, we required R. What is R that we found? 90 minus IC. Okay, so instead R we can write as sine 90 minus IC. And we know the formula. Sine 90 minus theta is what? Cos theta. Look at sine 90 minus theta is cos theta. That is the formula. On account of that, sine 90 minus IC, it becomes cos IC. So look at students, I'm going to write here simple cos IC. Understood students? Now cross multiply. Look at, you can write this. I'm going to remove the upper part. So finally we can write as, yes, cross multiply. We have to find sin alpha. So what should be sin alpha? Cos IC, okay, multiply with mu1 by mu2. Look at students, cos IC multiply with mu1 by mu2. And finally we require alpha. So transfer sign at that side, sin inverse, in bracket we can write cos IC mu1 by mu2. Okay students? Now finally, alpha as it is, this is sin inverse. Okay, we can write first of all mu1 by mu2. This is cos, and what is IC? We'll put the value of IC. Look at students, what is the value of IC? The value of IC is what? That we found as sin inverse mu2 by mu1. So here I'm going to write sin inverse mu2 by mu1. Okay. So I think which one is the correct option? Look students, out of these four options, sin inverse mu1 by mu2 cos sin inverse mu2 by mu1. B is the A is the correct option. Okay. So what should be the angle of this alpha for this total internal reflection and for this slab? The alpha should be sin inverse mu1 by mu2 cos sin inverse mu2 by mu1. Option A is the correct option. Method C. A glass prism of refractive index 1.5 is immersed in water. Look at students, ABC, that is a glass prism immersed in water. Okay, this we are given as water. Or refractive index 4 by 3. So refractive index of water is 4 by 3 and refractive index of this prism is what? 1.5. Okay students, what is asking? A light beam incident normal on the surface on the face AB. Look at, a light beam is incident normally like this. This is the normals. Okay, this is normal on the surface AB, on the face AB, is totally reflected to reach on the face AC. It is totally reflected and reach to the face AC like this. Okay, if sin theta should greater than equal 8 by 9, sin theta, okay, lies between 2 by 3 and 8 by 9, sin theta less than equal to 2 by 3, sin theta greater than equal to 4 by 3. Okay, so you can see the question students. I'm going to remove the question part. So we have to find condition for TIR. What should be the angle of incident so that the light suffers like this? It comes, okay, it is coming normal to the AB, okay, and it should passes through the surface AC. It should be totally reflected from the surface AC. So for that we have to find the condition. We have to find the angle of incident. Look at students, I'm going to make the prism separately. This is the face A, B and C. A light ray is incident and it is suffers. This is called TIR, total internal reflection. This angle we are given as theta. Light is coming normal. So this is what? 90. This is theta 90. So it should be what? 90 minus theta. Why? Because the sum of the three angle of a triangle is 180. So it should be 90 minus theta. This is normal. Okay, this is 90. If this is 90 minus theta, it will be theta. So this theta we have to find for suffers TIR. The light should passes through the surface AC like this. For that condition, passing the light from the face AC, we have to find the angle of value theta. Okay, look students. First of all, I am going to apply the condition of TIR. Look students. For total internal, okay, reflection, what is the condition? Theta should greater than equal to, okay, critical angle IC. Theta should greater than equal to critical angle IC. What is critical angle IC? It is that angle, okay, in denser medium. For correspondence, angle of refraction rare medium is 90. So we have to find, okay, taking sine both the side, it should become sine theta, becomes sine IC. Now students, for getting this sine theta, we require sine IC. How can you find sine IC? Now students, for finding sine IC, I'm going to apply the condition. Sine IC is what? Mu 2 by mu 1. Mu 2 is the refractive index of water, mu W. Refractive index of water, and mu1 as refractive index of glass prism. What is mu water? We are given the refractive index of water we are given as 4 by 3 and refractive index of glass we are given as 3 by 2. Okay, so 4 by 3 multiply by 2 by 3, 8 by 9. So sin IC we are, look at sin IC we are having 8 by 9. So this sin IC replaced by 8 by 9. So what should be the correct answer? Sin theta should get an equal 8 by 9. So A will be the correct option. When light enter normal perpendicular to the face AP, so what should be the condition to pass like this? Okay, for totally reflected, this is called total internal reflection. For total internal reflection from the face AC of this light, the sin theta should get an equal to 8 by 9. So option A is the correct option. Okay students. Now students, question number 4. A ray of light incident normally on one face of a right isosceles prism is totally reflected as shown in the figure. Look at students. ABC is a isosceles triangle. Okay, a ray of light incident and it's totally reflected. Okay, and coming normal to the surface. what must be the minimum value of refractive index of glass? We to find its refractive index mu. Okay, how can you find? Look students, you can see the question. I'm going to remove the language of this question for the solution. Okay. Look students, we know the condition. Now students, say we know the formula sin IC equals to 1 upon mu on behalf of TIR. We did before in the previous questions. Okay. Now students, first of all, what is IC? IC is critical angle and mu is the refractive index. Now students, the condition for TIR, the condition for total internal reflection, that incident angle, this is the TIR. Okay, TIR is taking place, a ray of light incident, it is reflected, this is called total internal reflection. And for this TIR, for total internal reflection, incident angle should greater than critical angle, greater than or equal. We can take greater than or equal. Okay, taking sign both the side, they come sign and they come sign IC. Okay, greater than equal, we can add greater than or equal. Sin IC is greater than equal to sin I is greater than equal to sin IC. Now students, we know what is I. Incident angle we are given in this prism as 45 degree. Here I am going to put the value of 45 degree. And sin IC, that is the condition of TIR 1 upon mu. Instead mu we can take n also, that is the refractive index. We can represent refractive index by mu or n. Here I am going to put 1 upon mu. Sin 45 is 1 by root 2, 1 upon mu. Okay. Taking reciprocal both the side. So 1 upon root 2 become root 2. On taking reciprocal, sign will also change. This become mu. Root 2 less than equal to mu. And what is root 2? We know 1.414. So what should be the value of mu? That is 1.414. Option A is the correct option.